e to the x times y equals 3 cos x. We want to show it leads to this differential equation. So let's differentiate term by term then. Gives, differentiating gives. So this is a product, so u to uv, so it's u times the v dx, which is y dashed, plus v y times the u dx, which is e to the x, is equal to, and cosine goes to minus sine, and there's 3 lots of. So it's minus 3 sine x. Differentiate again then. This now is a product, so it's u times the v, which is y double dash now, plus v times du. So that's the product differentiated, that's that one differentiated, plus this one now. This is also a product. So it's u times the v plus v times du, which is y dashed, isn't it? And that's equal to minus 3 lots of, and sine differentiates to cosine, goes to cosine. And we can replace that by the minus of this. Okay, so that tells us then, so e to the x times y double dashed, y dashed and y dashed are here and here, so there's plus 2 lots of e to the x y dashed. There's a y e to the x here, but this minus, this 3 cos x here can be replaced by e to the x times y in there. But there's a minus, so when we bring it over it'll be a plus, and it can come to be with this one as well. So I have plus 2y e to the x equals 0. E to the x times y equals 3 cos x. We want to show it leads to this differential equation. So, okay then, let's have a go at this then. So differentiating and see what we get. Gives. On the left we've got a product, so we use the product rule, so it's u times the v dx, which is y dashed, plus v, which is y, times the u dx, which is e to the x, is equal to, cosine goes to minus sine, and it's 3 lots of. So it's minus 3 sine x. Now we differentiate once more. So we've got another product here, so let's use the product rule, u to v dx. Differentiate that, you get y double dashed, plus v times du dx. That's that term here differentiated using the product rule, plus, and then this is a product again, so it's u times the v dx plus v times du dx is equal to, sine differentiates to cosine, and there's minus 3 lots of. So that's what we've got then. Now the 3 cos x can be replaced here by the e to the x times y with the minus, and when we move it over it will come to be with this one also. This is another y e to the x here. So we're going to get 2, and this will then be a 0. So we can just write that down now. So e to the x y double dashed plus, there's a y dashed and a y dashed both times by e to the x, so it's 2 y dashed e to the x's. And as we said, this can be replaced by e to the x times y. With the minus, move it over, it becomes a plus. We get plus 2y e to the x, and then there's nothing left on that side. Divide by e to the x then. Gives, and we get, divide this by e to the x, it just leaves y double dashed. Here we're just left with 2y dashed, aren't we? Plus, here we're left with just 2y, and 0 divided by a non-zero number is 0. And e to the x is non-zero here, so there's no problem there at all.